गुड मॉर्निंग फ्रेंड्स। आज हम केमिकल प्रॉपर्टीज ऑफ ईथर के बारे में पढ़ेंगे। इन ईथर देयर इज द CO bond which cannot be easily ruptured or cleaved. Ethers behaves like a very weak base and acid. Ether is far less basic as compared to alcohol. ईथर में CO बॉन्ड जो होता है उसको आसानी से तोड़ा नहीं जा सकता है। ईथर्स में वीक बेस है और एसिड है। ईथर इज फार एसिड एज कंपेयर टू द अल्कोहल। बेसिक कैरेक्टर: ड्यू टू द प्रेजेंस ऑफ द इलेक्ट्रॉन्स ऑन ऑक्सीजन ऑफ ईथर मॉलिक्यूल it behaves like a weak base. Ether react with a strong acid to form the oxonium salt. With acid ROR plus HCl, so it gives the R2OH positive and Cl negative acid the oxonium salt बनाता है. Ether CH3OCH3 react with the HCl and they form the oxonium salt and chloride. Reaction with HBr ROR react with the HBr, then the ROR positive, HBr negative. These salts are stable at low temperature and in a strongly acidic medium. They are decomposed by water to give the back ether and acid. ROR react with the H2SO4, then the R2O positive H, HSO4 negative, dialkyl oxonium hydrogen sulfate बनता है. Next, twice molecule of H2SO4 give the SO3 plus HSO4 minus and H2O. R2O plus H obtained from the acid, then the oxonium ions, then the R2O positive SO3, then ROSO3 R positive, R ऑक्सीजन का पॉजिटिव चार्ज आ जाता है एंड इट गिव द R positive plus RHSO3 SO4. Now R positive, that is the carbocations, react with the HSO4, then it forms the alkyl hydrogen sulfate RHSO4. Next, from formation of etherate. Due to the lone pair of electrons on oxygen, they are readily form coordinated compound with Lewis acid, such as a BF3 are known as the etherate. ROR plus BF3, so it gives the RR O positive, BF3 negative. Next, cleavage of oxygen bond. Carbon-oxygen bond in the ether can cleave when ether is treated with the strong acid like the HX, resulting in the formation of alkyl halide and alkanols. ईथर की HX से रिएक्शन करते हैं तो अल्कोहल और अल्काइल हैलाइड बनते हैं. If ether is treated with the excess of HX, then only alkyl is formed. ROR plus HI, it gives the alcohol plus RI. ROH react with the HI to form the RI and water. Next, order of the reactivity of the halogen. HI is greater than HBr than HCl. Mechanisms: SN2 or SN1 depending on the structure of ether. Primary alkyl group react with the SN2 where tertiary butyl group react by the SN1 mechanism. Now SN2 mechanism, ROR ether react with the HI, it give the oxonium ions plus I negative. Now this I negative react with the oxoniums, then transition state is formed, IRO positive RH. So it gives the Ri plus ROH, that is the weak base good leaving group. Next, mechanism of the SN1 reaction, RO positive HR reaction is slow and it gives the carbocations plus ROH weak base. Now this R positive and I negative reaction is fast and the Ri is up. In case of unsymmetrical ether, the less hindered alkyl group form the alkyl halide. Thus, if one of the alkyl group is methyl and the other is the primary or the secondary alkyl group, methyl halide is always formed. That means nucleophile attack preferably the less hindered alkyl group. CH3OC2H5 react with the HI to it give the CH3I plus C2H5OH. Now CH3CH2CH3OCH3, that is the N-butyl isobutyl methoxyisobutane react with the HI to give the corresponding alcohol plus CH3I. SN1 mechanisms, methyl tertiary ether react with the HI, it gives the methyl alcohol plus tertiary iodide. CH3I is not formed. This follows the SN1 mechanisms because the tertiary butyl carbocations being more stable is formed preferentially. Next, mechanism, tertiary butoxide, tertiary butyl methyl ether react with the HI, it forms the oxoniums plus iodine negative. Now, here the protonation takes place. Now, this proton slow reaction and tertiary butyl carbocation is formed with the methyl alcohol. Now, this tertiary butyl carbocations react with the iodide. Reaction is a fast and tertiary butyl iodide is formed. Giesler's method for estimation of the methoxy group. मिथॉक्सी ग्रुप का एस्टिमेशन हम जीजल मेथड से करते हैं, जिसमें कि डैश OCH3 react with the HI boil and the OH plus CH3I. This CH3I titrate with the AgNO3 solution and we obtain the AgI precipitate. The number of moles of the silver iodide indicate the number of alkoxy group in the compound. कि यहाँ जीजस मेथड में हम यही बता सकते हैं कि जितने CH3I ग्रुप बनते हैं उसका मतलब उतने ही उसमें मिथॉक्सी ग्रुप प्रेजेंट होते हैं।